What do you think about all those robots out there, huh? Wow, well, welcome to Autodesk's Design Night, and thank you so much for being here with us tonight as we explore the amazing world of robots. We have a real nice program for you, not just in here tonight with our panelists, but all the activities that we have out here. If you hadn't had a chance to do it yet, so many things to explore. You can build sumo bots over here. You guys know what sumo bots are? You know what sumo wrestlers are? Enough said. Check out the sumo bots. There's a couple of different telepresence systems here that you can check out. Lots of interesting stuff for you to see here tonight. And then, again, this amazing panel of folks we're going to talk to. And then, of course, we just... Hi, R2. Hey. What? The well? Luke is in the well? Come on, some of you get that. No, what really, R2, what's going on? Oh, thank you. Yes, got it. Thank you. How about a round of applause for R2 tonight, huh? Thank you. Normally droids have to wait outside, but come on, you guys have to. Some of you are laughing. Okay, I know the nerd level is pretty high in here. So R2 just reminded me that there are several people here that you should definitely shake hands with while you're here. One of them, for example, is the father of computer graphics. He's going to be embarrassed that I'm doing this. Don Greenberg from Cornell University is here. I can tell you, Don, Autodesk would not exist today if it hadn't been for the work that Don did in computer graphics and continues to do. As a matter of fact, he's here consulting and spending time with engineers here at Autodesk. So he is continuing to help push the edge of computer graphics. And that's something we do a lot of here at Autodesk. We make tools, and as you know, our software tools are pretty graphic intensive. And the stuff that happens underneath to make these tools possible is thanks to people like Don. So thank you, Don. We appreciate you. Also here tonight, I have to say, is Mark Hatch. Mark, wave your hand. Mark's the CEO of Tech Shop. Yeah. And Mark's going to be the speaker at Design Night next month. Don't miss it. It's going to be great. And Mark, thank you so much. Tech Shop provided the sumo bots tonight, thanks to Mark. So thank you, Mark. And then finally, one big round of applause for all the people who brought robots and displays and all the other stuff that's out there. We appreciate you guys so much. Thank you. Okay. Here we go. Okay. So, said, yeah, there he is. So, whoa, too far. Okay. I am Jonathan Knowles, and I work here at Autodesk. I'm part of the office of the CTO, the Chief Technology Officer. He's here tonight as well, so is our CEO. If you see him, shake their hand. They're fun, interesting guys. They live in Berkeley, so like totally, man. They're like totally cool, you know? But say hi. They're good guys. We hope that you tweet, Facebook, Instagram, social cam, do whatever you want about the stuff that you see here at Design Night. That happens to be my Twitter handle. I'll be introducing our panelists to you here in a minute. Before we get started, though, we wanted to just prime the robotics pump and talk a little bit about robots. It's something that we, as a species, have been thinking about for a long, long time. This is, and probably long before this, but I thought this was a good place to start. Anybody know what that is? That's Leonardo da Vinci's Mechanical Knight, right? 1495, he sketched out the plans for a mechanical knight. We're going to jump ahead to the 1800s, the steam man. So steam was the energy source, right, back then, and people thought, hey, why not? Why not have robots do this kind of work for us, and we'll power them by steam. Or else they just thought, hey, everyone wears a top hat, so it's natural that our robots would be powered by steam and have smoke coming out the top. Robots have certainly inspired many science fiction authors over the years. This, of course, is from Fritz Lang's movie Metropolis. This is Robbie the Robot, right, from Forbidden Planet. If you is Robbie actually in a place where mere mortals can see it at Intel? So Robbie is in the office of the CTO at Intel, as a matter of fact, just down the road. Very exciting that he lives here in Silicon Valley. We know who this is, right? Commander Data. Yeah, Roddenberry over here. He's like, yeah, I know who that is. Yeah, it's my man, Data. How about this guy? C-3PO. Wow. So I was wondering about the ratio of Trek, Wars, and Dancing With that was here. Come on, does that take a minute for you guys to get that? I guess it's Wars that's the winner of that. Okay. Many people, I know, Maurice, my colleague here and good friend Maurice Conti, he's saying boo because he's a Dancing with the Stars guy. That's his thing. Many people think that this is our robot future, right? Skynet, it's here. It's happening. This is what we have to look forward to. So maybe, I don't know, right? Is this what we're going to see? I think so, potentially, right? There's lots of different kinds of robots. This one tends to freak a lot of people out. I'm not sure why. This is DARPA's big dog robot. And some of you are kind of nodding your heads like, yeah, it freaks me out. I think it's a thing of beauty. I was talking with my friend Bryan David Johnson here, and both of us think it's a beautiful robot. It can follow a soldier around. It can carry a lot of stuff through lots of different terrain. DARPA's also doing some interesting work with humanoid robots. This is an interesting one because in other videos that you can find online, there's someone who comes in and gives that robot a big push and he stabilizes himself and keeps on going. Maybe we're not so far from that future in Terminator. Certainly these are robots. My colleague from Autodesk here, John Pittman, says, yeah, those are robots with wings. John, I think you're right. They're robots with wings. And guess what? You can go to DIYdrones.com and build your own robot with wings and put sensors and cameras on them pretty easily. And they don't just fly around individually. I have one. I play with my dog in the backyard, and she runs around and chases it. But check this out. Swarm behavior. Check. Swarm behavior with drones. The Star Trek movie in London just last week used something similar to this. And they took a bunch of these drones and they lit them and they had them fly over the city of London and they did the Starfleet logo in the sky. It was amazing, absolutely amazing. This one might be a little hard for you to see. This drone is going to throw this pole and that one is going to catch it. Look at that. They're getting a little scary, aren't they? This, of course, is DARPA's famous hummingbird drone. So this is the actual hummingbird drone right here. This is its video feed that it sends back. Some of you know the amazing inventor Dean Kamen. We were at the TED conference with him last year when he dropped it. That's a $10 million hummingbird. The bottom broke off, but apparently that happens a lot. So you should have seen the look on Dean's face when he dropped the $10 million drone. This is interesting work being done by some folks at Brown University, and I think Hod Lipson from Cornell's even involved in this. These are 3D printed bat wings for drones to make them look like bats. 3D printing and robot conversion. How about the Dragonfly drone? Right? Robots with wings. We all have probably seen this one. You can pick up the Parrot at any Brookstone for $300. What I think is kind of interesting about this is the European Space Agency has a free app you can get that lets you control your Parrot drone. And what they're doing is it's a game for docking, and they're trying to collect data from users to better understand how to fly drones. And you, playing the game, are contributing to their user research when you do that. NASA, of course, has a humanoid drone. This is Robonaut 2. Robonaut 2 has been in space. NASA has the Robonaut 2 challenge that if you're really into robotics and you're really into space and you want to do some interesting stuff, go check that out and see if you can come up with some clever ways. They have an open contest for people to get involved in robotics in space. Robots are happening at the Kickstarter level now, right? This is Fritz, your robotic friend, and Fritz is a robotic Kickstarter project to help teach kids about robotics, right? When some of us, oh boy, I'm gonna say my age here, were little, we played with things like erector sets. And that's how we learned a little bit about design. But it's a wonderful thing that things like this will be available for kids as they learn about robotics. Lots of things happening with telepresence robots. We have several here tonight. Anybot is here. You might have seen that. Fellow robots, Tasha, who's one of our panelists, is from that company, a co-founder of that company. I've personally used one for over 3 years here at Autodesk. They're very popular now in medicine. And speaking of medicine robotics, we have robotic surgery happening. Now today, it's a doctor controlling a robot remotely to do incredible surgery. If you take a look at the Da Vinci systems, one of their videos shows this system peeling the skin off a grape. That's the kind of dexterity they have. Imagine when we combine this kind of robotics technology with the kinds of things we're seeing in artificial intelligence with things like Watson. Remember when Watson defeated the Jeopardy champions? Right? So we're seeing some advancements. We're not quite to strong AI yet, but we're moving along that path, and what a convergence that's going to make. How about small robots? Robots that you put inside you to do things. Maybe they're running around inside getting bad things out of you. Or maybe they're monitoring you. This stuff's real. This stuff's happening now. These are small bots. How about really, 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 really small robots? These are DNA nanorobots. George Church at Harvard, who we at Autodesk have been working very closely with for a couple of years now. One of the fathers of human genomics. This is the result of some of his work. DNA nanorobots for the targeted delivery of cancer treatment. Imagine simple little robots that have a hinge, a sensor, and the ability to find cancer in the body, open and release the thing necessary to attack that, so you don't have to do radiation therapy or chemotherapy. That's the world we're moving into. Robots are taking our jobs. They took our jobs. Okay, the South Park people are laughing. That's a Bot and Dolly. Jeff Linnell from Bot and Dolly, the CEO of Bot and Dolly, is here tonight. Motion control cameras doing amazing things for us. So much for your job at Starbucks or Pete's, or this is LatteBot. Now, LatteBot doesn't just make a latte. LatteBot takes your picture with the camera and draws your picture on the top of your latte. Good luck with that, barista downstairs at Starbucks. Okay, you thought about a career at the Gap or at Bed Bath & Beyond? Don't. This is the famous towel folding robot. Can pick up a towel from a stack of previously unseen towels and do this over and over and over again. Yep. I know, I want one, right? Uh-oh, got a flat tire on 280, no problem. You call AAA and they'll send the robot out to replace your tire for you on your car. How about your next trip to Vegas or Atlantic City or Macau, wherever it is you go to gamble? Very likely could be a robot dealing cards for you in the future. Do you have to tip them? I don't know. Now this one scares the hell out of me, because don't you just see Optimus Prime or a Decepticon when you see that? Look at the size of that thing. Look what it's doing. Clearly they are going to be our lords and masters, right? And what about this? Do we need to start thinking about teaching robots right from wrong? It's clearly something that's in the popular culture. What about perp bots, crime bots? You think the criminals are going to send something like this into the bank up to the teller and say, look, I'm going to shoot you and blow up if you don't fill my little box in the back with money, right? Actually, the cartels are kind of doing some things like this already. How about companion robots? You know, something we've clearly been thinking about for, you know, a long time. And I know, not just the guys, but everybody's been thinking about it as well, because, you know, everybody needs a big, strong robot. Oh. And now we're going to finish with this and then go to our panelists. This is the current state of human size robots and the capabilities they have with regards to motion, to look like us and act like us. That's my favorite part, the little Arnold, you know, muscle man move that it does right there. So we're getting really good at some of this stuff. Let's go ahead and bring up our panelists. And if you'll come up when I introduce you. Our first panelist, Eugene Roddenberry Jr., President and Director of the Roddenberry Entertainment, also the Roddenberry Foundation. Eugene Wesley Roddenberry Jr. is the guardian of the Roddenberry legacy and champions its timeless and universal ideals to new generation through creative and inspiring science fiction productions, merchandise, publishing, underwater adventures, and philanthropy. As the son of legendary science fiction producer Gene Roddenberry, whose Star Trek series changed the face of television and continues to inspire today, Rod has followed in his father's footsteps to be a catalyst in the creation of a world where humanity works together for the greater good. Rod became Chief Executive Officer in 2001 of Roddenberry Entertainment, a science fiction leader with a tradition of groundbreaking entertainment. Roddenberry Entertainment builds on the best of Gene Roddenberry's work and continues to pioneer the development of a multimedia portfolio of smart and proactive science fiction that incorporates graphic novels, comics, television, and film projects, including the critically acclaimed Trek Nation, which debuted in 2011. Trek Nation is the documentation of Rod's 10-year journey to explore his father's life. The undertaking inspired him to fully embrace the vision Gene had for the world and invest himself in its future. One expansion of this was the founding of the Roddenberry Foundation in 2010. The Roddenberry Foundation funds paradigm-changing solutions to critical global issues in science and technology, the environment, education, and humanitarian advances. Please welcome Rod Roddenberry. Next is Bryan David Johnson, futurist and principal engineer at Intel. The future is Bryan David Johnson's business. As a futurist at Intel Corporation, his charter is to develop an actionable 10 to 15-year vision for the future of technology. His work is called futurecasting, using ethnographic field studies, technology, research, trend data, and even science fiction to provide Intel with a pragmatic vision of consumers and computing. Along with reinventing TV, Johnson has been pioneering development in artificial intelligence, robotics, and using science fiction as a design tool. He speaks and writes extensively about future technologies in articles and scientific papers, as well as science fiction short stories and novels, science fiction prototyping, designing the future with science fiction, screen future, the future's entertainment, computing, and devices we love, fake plastic love, and nebulous mechanisms. The Dr. Simon Egerton stories, those are just a few of the things he's written. He has directed 2 feature films and is an illustrator and commissioned painter. Please welcome Bryan David Johnson. Next up, Tasha McCauley, co-founder and director of user experience, Fellow Robots. Tasha loves building robots. After working as a teaching fellow in artificial intelligence and robotics at Singularity University, she joined the faculty as director of the Autodesk Innovation Lab, where she taught students about robotics and other rapidly accelerating technologies. She is a director of the 10 to the 9th Plus Foundation, an organization focused on empowering exponential change worldwide. Tasha co-founded Fellow Robots in 2011. Please welcome Tasha McCauley. And our last panelist to be introduced, Jeff Linnell, the CEO, the ECD, and co-founder of Bot and Dolly. Jeff Linnell is an executive creator, director, and co-founder at Bot and Dolly, and his sister company Autofuss, a production and advertising collective. In 2006, Linnell co-founded Autofuss with his longtime friend and colleague, Randall Stoll. Bot and Dolly, Autofuss's sister company, was spun out after Linnell and Stoll realized that robotics work they were doing for Autofuss presented him a much bigger opportunity and could also address more markets goods than just film production. Dolly now produces software and control interfaces, as well as robots for film and video production, motion graphics, manufacturing, and fabrication. Previous to co-founding AutoFuss and Dolly, Jeff was a technical director at RGA in New York and founder of the broadcast design company Ultraviolet, now UV Factory. Jeff's first forays into robotic control started when he wanted to expand his abilities as a director of photography. To accomplish this, he designed a tabletop motion control robot, affectionately known as Maxine. Jeff's work has been featured in major motion pictures and campaigns for clients such as Adobe, Nike, Chevy, Google, Facebook, Microsoft, Sprint, Gillette, Canon, and Sony. Please welcome Jeff Linnell. Holy cow, do we ever have a group for you? And there's no way we're going to be able to get through all this tonight with these folks, so be sure to talk to them afterwards. Okay, I'm going to get things started by asking the first question, and I'm going to throw it out to Bryan David Johnson.
Yes.
TikTok, Robbie, C3PO, Johnny 5, Data, or Bender? Go.
C3PO.
C3PO. Do you wish to elaborate on that?
What's that?
Do you wish to elaborate on that at all?
Obviously, it chokes you up, so that's why it's so important.
Excellent.
No, C3PO, because as a futurist, I spend a lot of time sort of traveling around talking to people about the future, especially talking to roboticists. And when you ask a roboticist about why they get into robots, they'll usually say, well, I want to help humanity, I want to fix this, I want to do that, I want to do this, and then, okay, great, and then we get off the stage. And then the roboticist comes over to me and goes, well, you know the real reason I got into it? Because I want to build C3PO. And usually it's the female roboticists who are the ones who say they wanted to build C3PO.
Interesting. Very good. Okay, who wants to take this? What differentiates a robot from a smart machine like an iPod or an iPhone? Tasha.
Yeah, it's an interesting question. Can you guys hear me?
Can you hear Tasha okay?
Am I audible? Yes, okay, good. That's a really interesting one.
We might have to close those doors.
I just looked up robot in the dictionary the other day, and it said it's a machine that can carry out a complex series of actions automatically. And I don't actually think that does anything to distinguish a robot from a smart device or anything we might have in our pocket. And actually, in fact, most robots, there are many, many robots that can't carry out a complex series of actions. So I think probably what distinguishes a robot from a smart machine is that the robot has a presence in the physical world, and it can take action on the world, and it can perceive things about the world, and then learn about it, make decisions. It's too soft.
Here, use my mic for now, and we'll get another handheld mic.
All right, can you guys hear me now?
There we go.
All right, that's better. Anyway, I was saying that what distinguishes a robot from a smart device like a phone is that the robot can look around its environment or feel its environment, take in information, and then use that info to make decisions about the world and then take action on the world. And that's not something that an iPod can do or that a phone can do. So.
And it doesn't get any easier, because I saw out there, did you guys see it? The little iPhone that's plugged into the little device that makes the iPhone
Yeah, so that's building
robot.
a robotic interface for, your smart device and giving it a robot to act on the world through.
Yeah, I mean, because at Intel we have a very specific definition for, which is, so we make computational power. So for me, a robot is computational power that can carry itself around.
Computational power that can carry itself around. There's some engineers at Autodesk here that I know that do that. Are they robots? Some would say yes. Great. Jeff, what do you think what is the most interesting innovation in robotics that you've seen recently?
Oh, actually, the balancing of the pole on the quadcopter is probably the most impressive recently. That and Big Dog now can also throw things with his tail, very large, heavy things that are even scarier than that video. But I think it's it's that abstraction to where you can start to accomplish real-world tasks, as simple as they are, just balancing something. It seems simple to us. Obviously, it's very complicated for a machine, and we're starting to get there. We're starting to get there with Big Dog and with a quadcopter that can balance a pole and throw it to another quadcopter. That's the sort of thing you couldn't do a year and a half ago, and it's going to be commonplace. And beyond that, we're going to get pretty far beyond folding towels pretty soon. But
pretty soon.
Those are the things lately that have struck me.
And Rod, if you had a robot right now, somebody said to you, I have a robot for you for your house. What would you want that robot to do for you?
Don't
worry, Heidi's not here, his wife,
Well, yeah, wife's not here. I think right now, walk the dogs.
Walk the dogs.
Walk the dog. And you know what? I need some help with some motivation. It's something that doesn't nag, and I'm not saying anyone in my life nags, but something that motivates and inspires me to kind of improve myself, my views, my.
So Tony Robbins bot.
Yeah. Yeah, I think so.
A 7'8" Tony Robbins bot.
But my biggest fear is Wall-E.
Yes.
As these robots start doing things for us, we're going to rely on them more and more and more. We're going to do less and less, potentially. But, there's another side to that robots may allow us to pursue things that we don't normally get to do. We're so busy trying to put food on the table that we don't have the opportunity to pursue our interests, what we love, what we desire. I think with robots doing the harder things, we might get the opportunity to pursue our interests. So I'm looking forward to that side.
Tasha, you have something
that
to say.
actually makes me think I would probably want a robot that understood my personality and my aesthetic and my sort of decision-making style, as best as a robot could, so that I could really delegate my, mundane stuff to the robot and really trust that it knows how to make a decision like me, and then I could focus on stuff that I think is more important.
I want to change my answer.
Yeah, change your answer.
I want a robot clone of me.
Ah.
Yeah, right. Okay, then. Exactly.
Dude. Yes. Bryan, are there any surprising players, either here in Silicon Valley, or maybe it's, Procter & Gamble, some Midwest company we don't know about that you're aware of that's doing something interesting in robotics that we would be surprised to hear about?
Well, I think with the consumerization of robots, and especially the drones that have been coming out recently, you have everybody down to house inspectors now using drones to inspect your roof. And that, to me, is the thing I find really interesting. You've got Big Dog and you've got the government stuff, and that's awesome, and it's really cool, and it freaks people out, but I think it's awesome. I was hoping you were going to say, I want Big Dog to walk my dog.
Yeah.
That would be perfect.
Awesome. Love that.
But for me, I think where the innovation gets really, really exciting is when you have, the local house inspector who lives in Grants Pass, Oregon, using them to look at roofs. Then we're putting the tools into people's hands when they can actually come up with sort of ingenious little uses for them that no one's ever thought of. So that's the thing for me. It's not so much companies, because there are a lot of companies, but I think the real groundswell is when you just get it into the hands of average people, and most importantly, when you get into the hands of kids.
Interesting.
I
Jeff.
think that one of the things that I found in my work, I work with rather mundane robots that have been automotive robots and manufacturing robots that have been around. This stuff's been there for 10, 15 years. But what I'm starting to see is it's not companies, but it's disciplines that are starting to work with these robots. In the last 4 months, I've met so many architects that are exploring industrial robots as a tool to do things that could not be done before. And the thing that's interesting about it, they're not necessarily just looking to cut wood or to stack bricks. They're looking at, what if I designed a building? What does this tool offer me that I did not have before? So they're creating design solutions that are vertically integrated with the manufacturing platform. And that's a market that did not exist prior. These robots were built to weld and to build cars, but you can't throw a rock and not hit an architecture school now that is getting involved in industrial robotics. And beyond that, the creative class and the tinkerers are starting to get their hands on these things and use them for applications that they weren't designed for. But people are starting to realize that they're incredibly useful, and it's inspiring. So I think it's not so much companies that are doing it, it's actually disciplines that are starting to adopt robotics and change the way that they work and change the way that they create whatever it is that they do.
Take just another moment and, if you can, in 40 seconds or less, talk about Bot and Dolly. Because I know I read it in here, and I know the types of things you use, but I think it'd be great for people to know a little more about that.
I don't understand it myself, but we started out using robots on film sets. People have been doing this. Star Wars was shot with a trench sequence was shot with a robot, 20 years ago. Might be 25 now. I don't. It scares me if it is. They were one-off machines, and we've taken industrial robots and applied them towards filmmaking. Since then, we've gotten into fabrication. We've gotten into camera calibration and vision systems based on robotics. So we are contemplating putting robots on tour with Lady Gaga to dance with her, things like that. So we're finding a lot of interest in the media and entertainment world that uses robots in non-traditional ways. And so our mission is to allow creative types and to disrupt industrial types into thinking about different ways to use these robots with different tools that are native to their process. And so we work with a muralist and give him a tool set that will allow him to paint with a robot without becoming a roboticist. And that seems to be a powerful place to be because not everybody is going to become a roboticist. And things need to evolve to a place where all sorts of disciplines can use robots in their work.
So, Rod, you talked about the robot that's going to walk your dog.
Yep.
Maybe that can also clean that great koi pond you have right there when you come in the front door.
Yes.
So if you have a bot that's doing these kinds of things for you, if somebody starts hitting your robot with a baseball bat, is that any different than somebody hitting your refrigerator with a baseball bat?
It's not, but I'll tell you, I don't know if it was you or someone else, but they were talking about a study done where they made this like puppy robot, and it had all the puppy eyes and everything, and had all the mannerisms, and then they told it to like beat the puppy. And it was amazing how many people were reluctant to do that because they associated this emotion, this feeling with it. And that's, I think about that too, and I wonder if I would crush this thing, I think robots, it's going to be really tough because they are a tool. They don't have emotions. I'm not getting into Data where he has the emotion chip yet.
Yeah.
But Data's a great example. I know we're talking science fiction.
Without his emotion chip, though.
Even without his emotion chip. Is it okay? And of course, they've done episodes on this to turn him off, to kill him. It's a fun thing to think about.
And something I think that is going to be a real part of our robotic future.
But but we can give robots emotions. So this is one of the things that I've been working on is you can create a system architecture for certain emotions because emotions give us the ability to truncate our actions. So if you and I are friends, the way we act and interact with each other is wildly different than if we are strangers. And so in a lot of the research that we've done, what we found is that actually if you can create a software architecture for friendship or even for love, it actually creates a very different relationship, a much more efficient relationship with people. And you can actually begin to change people's behaviors. You can change what they're doing around healthcare. You can
software architecture between people, did you say? Sorry, I wanted to...
A software architecture for a robot and a person. And the robot itself is kitted out with what is essentially has the appearance of emotions.
Yeah.
But they're artificial responses, are they not? I mean, you can't give it real emotions.
You're inspiring those real emotions in the person because they're mirroring the robot.
So just because it cries when you yell at it, though.
Yeah, it's not sad.
So I don't know. It's
For
a
now.
fun.
For now.
Yeah.
As we see advances in artificial intelligence, right?
Yeah.
Well, but as you talk to sort of a lot of psychologists and psychiatrists, a lot of it is actually the appearance of emotions.
Yes,
sure.
It's actually not the fact, are you happy or are you sad, but it's the appearance if you are happy or if you are sad. Mm-hmm. So you can actually be sad and show me that you're happy, and the fact that you have me is actually that you are happy. So I come at it like an engineer. So I think about emotions like an engineer. And so you can actually have the appearance of love, the appearance of this, and it actually has an effect.
Sure, and AI, the movie AI was great. I mean, I love the merger of robots and humans where, the two become one and it becomes a life form. I mean, I love that idea, but yeah, you're way out there, man. You're way out there.
That's a really interesting question because, in AI we study typically like the rational agent approach, which is where any action you take, it doesn't really matter the intelligence that got you there. We're not really studying sort of how the intelligence happens. It's really just whatever. And so a robot that's smiling is happy just by appearances, but that's not how humans work because, you can smile and feel terribly angry or sad. And so when you're calling it an emotion chip, are you seeing the transition, that will bring a robot from acting a certain way but not really, having any representation of that on the inside to actually feeling happy or sad?
Yeah, the system architecture for it actually isn't, this is where I get in fights with roboticists and AI folks, because
Fight.
No, because we've been working on non-deterministic robots.
Yeah.
So robots that make good decisions and bad decisions, because human beings make good decisions and bad decisions And that's why we learn much faster. So why would you have an AI that only makes good decisions? That means you're cutting it by at least 50%. We actually learn, we innovate by doing stupid stuff. So we're actually creating robots and thinking about AIs that actually are programmed to do stupid stuff.
Can I ask the audience a question? How many of you out there think that one day we'll have robots that can actually feel? Raise your hands.
Man.
And can I assume that the rest of you who didn't raise your hands think we'll never get there? Right?
Or you're just so scared you don't want to raise your hand.
Hey, you guys are wrong.
Okay. Yeah. Let's
So two things. First of all, go online. It's great, this magical portal out there called the Interwebs that has all this stuff on it. Check out some of the research being done into the work people are doing to give robots the appearance of emotions and have them smile and raise their eyebrows the right way and do all those things and see how it affects you. And we all remember the Luxo, the lamp. What was the Pixar?
Yeah.
Yeah, and how you felt about that little machine hopping around. That was years ago. Check out some of the other stuff. Now, to bring it back a little, Tasha, two questions. My first one is around telepresence robots. It's what you guys at Fellow Robots do. I've been using it for years now. Is it just Skype on wheels? What's the big deal?
I would say, most of them are just Skype on wheels right now, and I was actually just talking to Bryan a minute ago about this. Something we're working on at Fellow is changing it by really building a platform. It's open source hardware and software, and building a platform like an app store type thing where you can really customize this telepresence robot. For those of you who don't know, a telepresence robot is, and you've probably seen them out there, you can Skype into it and your face will appear on the screen, and then you can drive it remotely and it'll, be like your own little physical avatar somewhere. So to extend that, we're talking about endowing our robots with customizable sets of sensors. So if you want your robot to be able to, have powerful zoom and a pupil dilation sensor and an infrared sensor or whatever, and then it's also open source software, so you can write your own apps for it and be able to handle whatever kind of input your robot is getting. This will be really useful because then you've got basically what is an extension of your natural human capabilities in the telepresence robot. So, like your little superhuman avatar, instead of it just being Skype on wheels.
So we're almost out of time, but I have to ask this final question of you guys.
Yeah.
And you start. Okay. What can we do to get more young people, kids, especially young women, girls, involved in robotics?
Sure.
What can we do?
Yeah, well, I was actually really lucky because I went to a school that was the brainchild of a computer scientist named Alan Kay, and he basically had computers at every desk in the 80s and had us writing all of our reports in HyperCard and learning small talk and coding and stuff like that. And that early exposure to me was unbelievably valuable, and I think if we could reform the education system to really just incorporate that, because right now there's a perception that science is hard, and especially for girls, that a scientist is a guy with white hair and a lab coat, And if it was just brought into sort of everyday experience, and you, instead of writing a book report, you're programming an experience that might have multiple endings, that's fantastic for kids to be exposed to.
Thank you. Any other final thoughts on that? How can we get more kids involved?
Well, there's some of it here tonight, but First Robotics, Dean Kamen, we've recently gotten a little bit involved at our studio with it, but it's high school students doing incredibly ambitious challenges in robotics. It's a national competition. It's here. It's going to grow rapidly, but the students are passionate about it. The challenges are insane. The timelines are insane. But it's the kind of thing that people are spending all nights and weekends and a bunch of pizza on, and the results are pretty amazing. That didn't exist when I was a kid. I had the Erector set, and that's kind of where it dropped off.
Yeah.
Now you've got Lego NXT and things like that, but this is an amplification of it, and it's a pretty important program. It's good to see stuff like that.
I want to second that. I was just at the LA Regional Championships, and I'd heard about it for a while, and I went there and I saw the passion that these kids had for it. And something else I really liked is that they had all the schools participating in Los Angeles. So that was the privileged to the underprivileged, but it leveled the playing field because they were all operating with the same tools, and they all got to compete. And you see these kids, they're excited. They're spending weekends. They're staying after school. It may not be for everyone, but you hear stories of kids who had no direction, had no idea what they wanted to do, and they found it in this program. It's not the end-all be-all necessarily, but in terms of your question.
And they're here tonight. Talk to them. We've been involved with them for years at Autodesk. Before we go, we have one final video we are going to show, so let's make sure our audio is good. And, you know, we have music and dancing out there. I'll say thank you now to our panelists and ask you to thank them for being here tonight. We'll do Q&A? No. Okay, then I will also say, don't forget, next month, May 2nd, Design Night is Making It. Mark Hatch, CEO of Tech Shop, he's here tonight. He'll be speaking next week. They go on sale Monday, April 8th at noon. Okay, watch this video and then go get your groove on here at the Autodesk Gallery. Oh, yeah. Who knows this one? All the old people. This is the Brady Bunch. They still need our help. I love that.
I've got a perfect puzzle for you. Domo arigato, Mr. Roboto. Domo arigato, Mr. Roboto. Domo arigato, Mr.
A robot doing the robot.
Trouble 2 for the time. Come on, y'all, let's read this.
Walk like an Egyptian.
Okay, you have no excuse for not doing really well out on the dance floor out there tonight. Thank you for being here. Thank you, panelists. They'll be hanging around for a while. Have a good time at Autodesk, everyone.